In many countries, RCDs are required by law in certain electrical installations such as bathrooms, kitchens, and outdoor circuits where the risk of Welcome Electro-Tunes CEWP. A residual current device, RCD, is a safety device used in electrical installations to prevent electric shocks and fires. It detects differences between the live hot and neutral conductors of an electrical circuit, instantly cutting off power when it senses an imbalance. This imbalance can occur if electricity is flowing through an unintended path, such as a person's body. The principle behind an RCD is fairly simple. It continuously monitors the current flowing through the live and neutral conductors. Under normal conditions, the current flowing in through the live conductor should equal the current flowing out through the neutral conductor. If the RCD detects a difference in the current, meaning more current is flowing through the live conductor than the neutral conductor, it assumes some current is leaking through an unintended path, for example, a person's body. The RCD responds by quickly disconnecting the power supply. This imbalance can be caused by situations like electric shocks, wiring faults. The faulty appliances, the RCD typically cuts off power in milliseconds, minimizing the risk of severe injury or death due to electric shocks. How does an RCD work? Current monitoring. The device works by measuring the difference between the live and neutral wires currents. Under normal operation, these currents are balanced, meaning the incoming current live is equal to the outgoing current neutral. Sensing imbalance. If there is a leakage current, such as through a person's body or an electrical fault, the current between the live and neutral will no longer be equal. This difference is what the RCD detects. Tripping mechanism. When the RCD senses this imbalance often as low as 5 mA, it will quickly trip and disconnect the circuit, preventing further leakage and protecting anyone from potential harm. Types of RCDs. There are two common types. Fixed RCDs. These are installed in the distribution board and protect the entire circuit. Socket outlet RCDs. These are installed in specific outlets, protecting only the devices plugged into them. Why are RCDs important? Protection against electric shock. The most important purpose of an RCD is to protect human life. It disconnects power if a person is exposed to an electric shock, reducing the risk of serious injury or death. Fire prevention. An RCD can also prevent fires caused by electrical faults or insulation breakdowns, where leakage current might generate heat. Legal requirement. In many countries, RCDs are required by law in certain electrical installations such as bathrooms, kitchens, and outdoor circuits where the risk of electrical shock is higher. RCDs are widely used in residential, commercial, and industrial settings. They are particularly important in areas with a higher risk of electric shock, such as bathrooms, kitchens, construction sites, outdoor circuits. Areas with water or moisture exposure, for example, swimming pools.
Why are RCDs important? Protection against electric shock. The most important purpose of an RCD is to protect human life. It disconnects power if a person is exposed to an electric shock, reducing the risk of serious injury or death. Fire prevention. An RCD can also prevent fires caused by electrical faults or insulation breakdowns, where leakage current might generate heat. Legal requirement. In many countries, RCDs are required by law in certain electrical installations, such as bathrooms, kitchens, and outdoor circuits, where the risk of electrical shock is higher. RCDs are widely used in residential, commercial, and industrial settings. They are particularly important in areas with a higher risk of electric shock, such as bathrooms, kitchen tanks, sites, outdoor circuits, areas with water or moisture exposure, e.g. swimming pools. Conclusion to summarize. A residual current device or CD is a critical safety feature in modern electrical systems. It works by detecting any imbalance between the live and neutral current and instantly disconnecting the power supply if a leakage current is detected. This simple yet effective device helps protect against electric shock and electrical fires, ensuring the safety of both people and property. Regular testing and maintenance of your RCD is also essential to ensure it functions properly when needed. Always ensure your RCD is working as expected to keep your electrical system safe.
An arc fault circuit interrupter AFCI is a safety device designed to prevent electrical fires caused by arc faults. These arc faults typically occur when there is an unintended electrical discharge between two conductors, such as wires or cables, that can lead to overheating, sparking, and fires. AFCIs are crucial for electrical safety, especially in modern homes and buildings where older wiring may still exist. How does an arc fault occur? Before we dive into how AFCIs work, let's quickly review what an arc fault is. An arc fault is a dangerous electrical fault where the flow of current is interrupted or irregular, causing electricity to jump across an air gap. These arcs generate intense heat, which can easily ignite nearby materials such as wood, insulation, or fabric. Common causes of arc faults include damaged or frayed wires due to aging, wear, or mechanical stress, loose connections and outlets, switches, or electrical panels, nails or screws that pierce wires in walls during construction, overheated wires due to excessive current flow or poor connections. If left undetected, arc faults can lead to devastating fires. This is where an AFCI comes in. An AFCI works by detecting the presence of arc faults within an electrical circuit and automatically disconnecting the power before the arc can cause a fire. The device is designed to identify different types of arc faults, including series arcs and parallel arcs. A series arc occurs when there is a break or loose connection in the circuit, causing the current to jump across the gap. AFCIs are particularly good at detecting these types of faults by monitoring the electrical signals and looking for irregularities that suggest an arc is occurring. Parallel arcs. Parallel arcs happen when the hot and neutral wires come into contact with each other or another conductive material. The AFCI monitors the voltage and current flow to detect these potentially dangerous conditions. Once an arc is detected, the AFCI asterisk trips the circuit asterisk and cuts off the power, preventing further damage or fire. The AFCI can differentiate between normal electrical events like the operation of a motor or a switch and dangerous arcs, ensuring that only hazardous situations result in a trip. AFCIs provide an additional layer of protection compared to standard circuit breakers and ground fault circuit interrupters (GFCs), which are good for detecting other hazards like overloading or ground faults but do not address arc faults. Here are some key reasons why AFCIs are important. Prevention of electrical fires. Arc faults are one of the leading causes of electrical fires in homes, and AFCIs are designed to reduce this risk significantly. Early detection. AFCIs detect arc faults in their early stages before they can cause a fire, offering a high level of protection. Protecting older wiring. In older homes, wiring may not meet current safety standards. Protecting older wiring. In older homes, wiring may not meet current safety standards. AFCIs help protect homes with outdated electrical systems by detecting problems that might not be apparent with older circuit breakers. There are different types of AFCIs depending on their application. Combination AFCI. This is the most common type and provides comprehensive protection by detecting both series arcs and parallel arcs. Combination AFCIs are typically used in residential applications and are often required by modern electrical codes. Branch, feeder AFCI. These detect only series arcs and are used for specific circuits such as those in kitchen or living areas. Outlet AFCI. Outlet AFCIs are designed to be installed in electrical outlets and provide protection to the device plugged into the outlet by detecting arcs and the wiring connected to that outlet. AFCIs are typically installed in places where electrical fires are most likely to start due to faulty wiring or connections. For example, bedrooms, living rooms, hallways, kitchens, other areas with high electrical usage. In modern homes, AFCIs are required by electrical codes, for example, NEC 2017 in the US to be installed on all bedroom circuits, and many building codes around the world require them for new constructions and major renovations. How to test an AFCI. It's important to test your AFCI periodically to ensure it's functioning correctly. Most AFCIs come with a test button, which simulates an arc fault and triggers the device to trip, shutting off the circuit. Here's how to test it. Press the test button on the AFCI. Verify that the AFCI trips and cuts off the power. This indicates that the AFCI correctly detects an arc fault. Reset the AFCI by flipping the switch back to the on position. Always ensure to test your AFCI at least once every month to maintain safety. In summary, an arc fault circuit interrupter AFCI is an essential safety device that can significantly reduce the risk of electrical fires caused by arc faults in your home or building. It detects dangerous arcs in electrical circuits, both series and parallel, quickly cutting off power to prevent fire hazards. With the increase in electrical fires, AFCIs have become an important standard in modern electrical installations and are critical for enhancing overall electrical safety. By detecting arc faults early and shutting off power before a fire can start, AFCIs provide peace of mind and an extra layer of protection for both your family and property. Welcome to ElectroTunes CEWP. An RCBO residual current breaker with overload protection is a safety device used in electrical circuits. It combines the functions of a residual current device RCD and an overcurrent protection device MCCB or MCB. The RCBO protects against the primary electrical hazards, residual current earth leakage, protecting against electric shocks due to leakage currents or faults in the system. Overload and short circuit, protecting against excess current that can cause overheating or fire hazards. Residual current detection RCD functionality. Like a residual current device RCD, the RCBO monitors the difference between the live and neutral conductors in the circuit. Under normal operation, the amount of current flowing into the live conductor should equal the current flowing out through the neutral conductor. When there is an imbalance, it means some of the current is leaking or flowing through an unintended path, such as a person who is receiving an electric shock. The RCBO detects this imbalance and disconnects the circuit to protect individuals from electric shock. This leakage could be caused by faulty wiring, a damaged appliance, or a person coming into contact with a live conductor. Overload and short circuit detection overload protection. The overload protection function of the RCBO is similar to that of a miniature circuit breaker MCB. It detects when the current exceeds the rated limit of the circuit, either due to overloading too many devices connected to the circuit or a short circuit, a direct connection between live and neutral wires. If the current exceeds a preset threshold, the RCBO trips, cutting off the power supply and preventing overheating, fire, and further damage to the system. This ensures the safety of both the electrical installation and connected devices. An RCBO typically contains the following main components. Current transformer CT. This is used to monitor the balance between the live and neutral currents. If any imbalance occurs, the CT detects it. Electromagnetic or thermal trip mechanism. This detects when the circuit is overloaded or there is a short circuit and disconnects the power to prevent damage. Test button. A test button is included to manually check the functionality of the RCBO to ensure it will trip in case of an earth leakage or overload. Circuit breaker mechanism. This physically interrupts the electrical connection when the current reaches a dangerous level. Why is an RCBO important? Protection against electric shock earth leakage. The RCBO's RCD feature detects residual current or leakage current, which may occur when an individual is electrocuted. This ensures that electricity is quickly cut off, reducing the chances of injury or death from electric shock. Protection against overload and short circuit. Protection against overload and short circuit. The overload protection component of the RCBO safeguards against electrical fires caused by excessive current. If too much current flows due to an overload or short circuit, the RCBO disconnects the circuit to prevent overheating and potential damage to the electrical installation or devices. Space-saving design, RCBOs are highly efficient in that they combine two important safety functions, earth leakage and overcurrent protection, into one compact device, reducing the need for multiple units, for example, a separate RCD and MCCB, cost-effective. By combining the protection features, RCBOs help reduce the overall cost of electrical installations, saving money on both equipment and space in the distribution board. RCBOs are commonly used in a wide range of electrical installations, especially where personal safety is a concern. Residential homes, to protect users from electric shock, particularly in areas such as bathrooms and kitchens. Industrial applications, to safeguard machinery and workers from electric shocks and overcurrent issues. Commercial buildings, in offices and retail spaces, to ensure both safety and the protection of expensive electrical equipment. Outdoor circuits, for circuits that could be exposed to the risk of moisture or accidental contact with people. How to test and maintain an RCBO. It's crucial to ensure that an RCBO is functioning correctly to maintain safety in the electrical system. 1. Testing. Most RCBOs have a test button that simulates an earth leakage fault, allowing users to verify whether the device will trip in case of a fault. Visual inspections check for signs of physical damage or wear. The RCBO should not show any signs of burns, discoloration, or malfunctioning. Regular maintenance. For systems with RCBOs, regular testing and maintenance are important to ensure the protection device is working as intended. To sum it up, an RCBO residual current breaker with overload protection is an essential safety device that combines the critical functions in electrical protection, earth leakage protection, RCD, and overload, short circuit protection, MCCB. It safeguards both individuals from electric shocks and electrical installations from the dangers of overloads and short circuits. By detecting imbalances in the current, as well as preventing the flow of excessive current, RCBOs provide comprehensive protection, making them a vital component of modern electrical systems. Whether it's in residential, industrial, or commercial applications, RCBOs ensure electrical safety and reliability in a compact, cost-effective unit. Thank you for watching. Make sure to like, share, and subscribe for more detailed electrical content. And if you have any questions or want to learn more about electrical safety devices, drop a comment below. Stay safe.